mean purely a single neural network being able to accomplish reasoning
I don't stay up at
comprehension.
night worrying that that's going to happen. And I'll just give you two examples. One is a guy at DeepMind thought he had finally outfoxed me.
Yeah.
At Zergy Lord, I think is his Twitter handle.
Uh-huh.
And he said, he specifically made an example. Marcus said that such and such. He fed it into GP2, which is the AI system that is so smart that OpenAI couldn't release it because it would destroy the world, right?
Yes.
You remember that a
Yes,
few
of
months ago.
course.
So he feeds it into GPT-2. And my example was something like a rose is a rose, a tulip is a tulip, a lily is a blank. And he got it to actually do that, which was a little bit impressive. And I wrote back and I said, that's impressive, but can I ask you a few questions? I said, can it, was that just one example? Can it do it generally? And can it do it with novel words, which was part of what I was talking about in 1998 when I first raised the example. So a DAX is a DAX, right? Mm-hmm. And he sheepishly wrote back about 20 minutes later. And the answer was, well, it had some problems with those. So, I made some predictions 21 years ago that still hold. In the world of computer science, that's amazing, right? Because, there's 1,000 or 1,000,000 times more memory and, computations 1,000,000 times, you do 1,000,000 times more operations per second, spread across a cluster. And there's been advances in, replacing sigmoids with other functions and so forth. There's all kinds of advances, but the fundamental architecture hasn't changed and the fundamental limit hasn't changed. And what I said then is kind of still true. And then here's a second example. I recently had a piece in Wired that's adapted from the book, and the book went to press before GP2 came out. Mm-hmm. But we described this children's story and all the inferences that you make in this story about a boy finding a lost wallet. And for fun, in the Wired piece, we ran it through GPT-2 at something called talktotransformer.com, and your viewers can try this experiment themselves. Go to the Wired piece that has the link and it has the story. And the system made perfectly fluent text that was totally inconsistent with the conceptual underpinnings of the story. Mm-hmm. Right. And this is what, again, I predicted in 1998. And for that matter, Chomsky and Miller made the same prediction in 1963. I was just updating their claim for a slightly new text. So those particular architectures that don't have any built-in knowledge, they're basically just a bunch of layers doing correlational stuff. They're not going to solve these problems.
So 20 years ago, you said the emperor has no clothes. Today, the emperor still has no clothes.
The lighting's better, though.
The lighting is better. And I think you yourself are also, And
we found out some things to do with naked emperors. It's not that the stuff is worthless. They're not really naked. It's more like they're in their briefs and everybody thinks that. And so they are great at speech recognition. Yes. But the problems that I said were hard, because I didn't literally say the emperor has no clothes. I said, this is a set of problems that humans are really good at. And it wasn't couched as AI. It was couched as cognitive science. But I said, if you want to build a neural model of how humans do certain class of things, you're going to have to change the architecture. And I stand by those claims.
So, and I think people should understand you're quite entertaining in your cynicism, but you're also very optimistic and a dreamer about the future of AI too. So you're both.
There's a famous saying about being people overselling technology in the short run and underselling it in the long run. Right. And so I actually end the book, or Ernie Davis and I end our book with an optimistic chapter, which kind of killed Ernie because he's even more pessimistic than I am. He describes me as a contrarian and him as a pessimist. But I persuaded him that we should end the book with a look at what would happen if AI really did incorporate, for example, the common sense reasoning and the nativism and so forth, the things that we counseled for. And we wrote it. It's an optimistic chapter that AI suitably reconstructed so that we could trust it, which we can't now, could really be world-changing.
So on that point, if you look at the future trajectories of AI, people have worries about negative effects of AI, whether it's at the large existential scale or smaller short-term scale of negative impact on society. So you write about trustworthy AI. How can we build AI systems that align with our values, that make for a better world, that we can interact with, that we can trust?
The first thing we have to do is to replace deep learning with deep understanding. So you can't have alignment with a system that traffics only in correlations and doesn't understand concepts like bottles or harm. So, Asimov talked about these famous laws, and the first one was first do no harm. And you can quibble about the details of Asimov's laws, but we have to, if we're going to build real robots in the real world, have something like that.